Hello everybody. I want to do a video with an example of a while loop and make sure that you are doing the correct thing with Boolean expressions. First, I want to talk about Boolean expressions. So let's call it more on Boolean expressions. The important thing that many of you are missing is a Boolean expression in an if or a while must be inside parentheses. This is not parentheses. Is that close to right? Nope. Let's try it again. I'll let the machine take care of it. That is not the way Python does it. And I've seen quite a few of you making that mistake. So for example, we could have if x equal 9, see out, x is 9, \n, brace. A warning, by the way, those quotes don't copy into Python, into C++ properly. For some reason, they come out different in Word than they do in Python. I don't know why, but I've had that problem a couple of times. The point is that there's a parentheses around this outside thing, around that Boolean expression. Also, notice there's no semicolon on that line. It's not a statement that needs to be separated from other statements. It's the beginning of a statement. The full statement includes everything inside the braces. And the braces say everything inside here is controlled by the if. Now, another example would be like this. While x greater than or equal to 10 and x less than or equal to 20, see out, set w uh, 5 x plus plus brace. Now that prints 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Because it prints, oh, I'd have to have a number out here. Let's say I start with x equal 10. So while x is greater than or equal to 10, and while it's less than or equal to 20, print it. Incidentally, don't you have some place in one of your homeworks where you have to check and see if numbers are between two things? I don't think this is the right way to do it, by the way. I think there's a better way. But that is the way. That is one way. I wouldn't recommend taking that exactly, though, for that homework. Points. How about prints? Now, the other thing that you've got to remember is that and is the two ampersands. You can't use the word and. That is Python. It is not C++. And or is the two bars. Not the exclamation points. Those are bars. And not is not. Now, why they did this, this is the way it is. These are the symbols that logicians use all the time. The and, well, they don't quite use those, but they're reasonable symbols. Python uses the words. We don't. And let's see. Oh, finally, equals is the two equal signs, and not equals is the exclamation point equal. And of course you have all the others. You have and, greater than, less than or equal to, and greater than or equal to. So that's the kind of things that you have to be careful of. Make sure you understand those. What I'm going to do is write a program. So let's jump to, here's my program. I will be taking a trip in a city, running errands. And in my city is a regular grid. So before I do anything else, let me show you what I mean by that. I'm going to go over here and bring up a grid. There is a grid. It's a little different than what you're used to. It's not the high school Cartesian plane. It's close, but notice I start at 1, 1, and I go, my numbers go up as I go down. If I were doing the Cartesian plane, I'd put the 0, 0 down at the bottom. The points are what are in the grids. You can think of those as the corners in your city. So this is the corner of First Avenue and First Street. And this is the corner of 3rd Avenue and 2nd Street. I've marked 1, 1 and 2, 1 and 3, 6. 3 is 1, 2, 3, and 6 is 1, 2, 3, 4, 5, 6. Now I'll talk about the rest of that in a minute. But right now, let me copy this and go back to here and put that in. It comes out kind of funny here and there. I can't help it. Things always seem to come out wrong. So I'm going to define distance. My city is a regular grid. I want to know how far I travel when I do a round trip from home to the places for the chores to home again. So I'm doing a round trip. The question is, how should I compute distance? Well, I can only travel on roads or sidewalks. So I need to know how many blocks from a point to another point. And the best way to look at this is right here. Let's say I'm at 210. Now, I'm going to travel to 75. So, how am I going to do it? Well, I'm going to go 1, 2, 3, 4, 5 places. Now I'm at 7. This was 2, 3, 4, 5, 6, 7. And then I'm going to go from 10 to 5. This was 10, so that's 11. 10, 9, 8, 7, 6, 5. And that was supposed to be where it was. 1, 2, 3, 4, 5. This should come down just a little. There we are. Now, I marked the M twice because I got to go this way and that way. This particular distance, the distance is the absolute of x minus k plus the absolute of y minus L. I use the absolute because I want negatives. So x minus k in this case is 7 minus 2. And y minus L is 10 minus 5. Absolute just means the absolute value. It's always positive. If the difference is negative, I make it positive. This particular distance has an interesting name. This is called the taxi cab distance, or sometimes Manhattan distance. Since if you were in New York, that's the way you would travel. And Manhattan is a very simple grid like that. So that's what it is. Now, as I said, don't even think about this in Boston. Only very few parts of the city are well gridded in Boston. Basically, when you get down to Back Bay, they start having a grid pattern. So this is what I want to compute. So what I'm basically going to do is start thinking up an algorithm to do this distance. I will input my home place, my home location, and the locations of the places I'm going. One by one. I'm not going to go back home each time. So for example, up here, I start out from here to here. If my next one is 11, 10, I'd go here. I go from where I am to the next one. So how am I going to do this? Here's my algorithm. I'm going to suggest we do the following. We input the home x and the home y, where I start. So my x and y for my home. We set our distance to 0. We haven't gone anywhere yet. And then we input the first city. We input next x, the first corner, pardon me, next y. So that's where I'm going to go next. And now I'm going to do something funny. I'm going to also set current x to home x and current y to home y. What I'm saying is that's where I am right now. Current will be where I am. So when I start out, I'm at home. And then, while next is not home. In other words, while I don't get back to the beginning, and I got to figure out how to write that. This is algorithm. I'm not telling you all the details yet. While that's true, what do I want to do? Well, I want to compute the distance from what the distance is now plus the absolute of current x minus next x plus the absolute of current y minus next y. So I made the move. I'm now at next x and next y. Well, current's not true anymore. Current is not where I am. So I have to change current to next. I have to move over. Well, if I have to do that, and that's change, not chance. CHANGE. Now I got to get the next place I'm going. So now I got to input next x and next y. Notice I did those in a very important order. I first moved myself to where next used to be, and now I'm going to a new place. And when I finish, I just have to output distance. That is an algorithm. I am not worried about all the details of semicolons and equal signs and all kinds of things like that. I've just said, how would I solve this problem if I were given it? The computer does not solve the problem, at least not now. The computer runs your solution of the problem. It just is faster. That's its basic, and it doesn't bore as easily, and it usually gets arithmetic correct, which I don't about half the time. But this is our plan. This is the way we intend to do this. So I'll copy this, and now I'll go and start up here, and I'm going to create a new project. And I'll call it running errands. And we'll be ready. So as usual, I'm going to copy my algorithm into here. So we'll have it if I need it. And now we can start thinking of how we're going to do it. Well, we do need using namespace standard. So let's see. I'll get rid of that, and I'll start looking at my algorithm. I got a whole flock of variables I need, so why don't I declare some of them? They're all integers, so there's no problem. That's home x, home y, next x, next y, current x, current y, distance. I'll start off at 0. I actually need 2 more. They're not visible up there. Absolute x and absolute y. Those are distances. I think I got everything I need. Now I go right to the algorithm and do what it says. I've set the distance to 0 already. I've got to input the home and home. So cout input home. That's right, this way. Input x and y of home. Cin home x, home y. And you find out if we were in class regularly, you'd find out I make this mistake about half the time, typing too fast. And the algorithm then says I got to get the next. So cout input net location, or I'll call it next location, x and y of next location. And again, cin next x and next y. And it said I also have to tell you where I am. I'm at home. So my current x is the same as my home x. And I wish I could spell current. And then I have the same thing for the y. I'm done with that, the parts before the loop. Now this is the way things currently usually run. I've got things to do before I begin repeating. I've done all of them. So now I'm ready to repeat. Well, I'm not sure I want to show you. I have to, I'm running a little late because I've got an event coming up. What I'm going to do is I'm going to stop here, and I'll be back in the next one in probably within an hour or so.